Here's some pictures of what most people associate when they think of chemistry. They think of scientists working on a bench with the different vials of different chemicals. They might think of a mad scientist, some of them boiling and changing colors. They might associate chemistry with chemical equations, thinking about how different things will react together to form other things. They might think about models of different molecules that can be depicted different ways. They might associate it with the periodic table of elements. And all of these things are a big part of chemistry. But what I want you to do in this video is appreciate what, at its essence, chemistry is all about. And chemistry is one of the sciences that really just helps us understand and make models and make predictions about our reality. And even something like the periodic table of elements, which you'll see at the front of any chemistry classroom, you take it for granted. But this is the product of, frankly, thousands of years of human beings trying to get to an understanding of all of the different complexity in the world. You know, if you look at the world around us, and it doesn't even have to be our planet, it could be the universe around us. You see all of these different substances that seem to be different in certain ways. You see things like fire and rock and water. Even in the planets, you see meteorological patterns. In life, you see all of this complexity and all of these different things. And it looks like there's just like an infinite spectrum of differentness out there, of different substances. Even in things like our human brain, the complexity and the electrochemical interactions. And you could imagine as a species, this is kind of overwhelming. How do you make sense of all of this? And it was not an easy path, but over thousands of years, we did start to make sense of it. And why it's very lucky for all of us to be born when we are now, or to be around when we are now, to be able to learn chemistry where we are now, is that we get the answer. And it's a partial answer, which is also exciting because we don't want the full answer. But it's a partial answer that takes us a long way. We realize that the periodic table of elements, that all of this complexity that we're seeing before, that at the end of the day, things are made of basic building blocks. Kind of, you can imagine, the Legos that really make up everything. And there aren't an infinite number of Legos. There's actually a finite number of them. We're discovering more all of the time. Well, not all of the time. Now new elements are not discovered that frequently. But there's a few of these elements that are disproportionately showing up in a lot of what we see here, these things that seem so different. Well, a lot of this is different compositions of elements like carbon and oxygen and hydrogen. And even the elements themselves are made of things like protons and electrons and neutrons that are just rearranged in different ways to give us these elements that have all of these different properties. So when you think about chemistry, yes, it might visually look something like this. These are obviously much older pictures. But at its essence, it's how do we create models and understand the models that describe a lot of the complexity in the universe around us? And just to put chemistry in, I guess you could say, in context with some of the other sciences, many people would say at the purest level, you would have mathematics. That math, you're studying ideas, which could even be independent. You're studying logical ideas that could be even independent of anything that you've ever observed or experienced. And a lot of folks that say if we ever communicate with another intelligent species that could be completely different than us, math might be that common language. Because even if we perceive the world differently and think differently in certain ways, math might be that common language. Then on top of math, we start to say, well, how is our reality actually structured? At the most basic level, what are the constituents of matter and what are the mathematical properties that describe how they react together? And then, or interact with each other. And then you go one level above that, you get to the topic of this video, which is chemistry, which is very closely related to physics. When we talk about these chemical equations and we create these molecular structures, the interactions between these atoms, these are quantum mechanical interactions which we do not fully understand at the deepest level yet. But with chemistry, we can start to make use of the math and the physics to start to think about how all of these different building blocks can interact to explain all sorts of different phenomena. This chemical equation you see right here, this is combustion. This is hydrogen combusting with oxygen to produce a lot of energy, to produce energy in the form and when we imagine combustion, we think of fire. But what even is fire at its most fundamental level? Why do we perceive this thing here? And chemistry is super important because on top of that, we build biology. And as you'll see as you study all of these things, there's points where these things start to bleed together. But the biology in, say, a human being, or really in any species, it's based on molecular interactions between molecules, between atoms, which at the end of the day is all about chemistry. As I speak, the only reason why I'm able to speak is because of really hard to imagine a number of chemical interactions happening in me right now to create this soundness, to create this thing that thinks that exists, that wants to make a video about how awesome and amazing chemistry is. And then from biology, you can build out on all of everything else. The sciences like psychology and economics, which of course, these things also will leverage math and other things. But this gives you kind of a sense of how we build up and how we explain the reality around us. And not one of these is more important than the other. These are all studying incredibly fascinating things that as human beings first became thoughtful about their environment, said, gee, why are we here? What is this place? Why do we exist? How do we exist? And chemistry builds models for us to understand interactions at a scale and a speed that we can't directly observe, but nonetheless we can start to make predictions. So that's what's really cool about this. When you study chemistry, you should not view this as some type of a chore that the school system is forcing you through. There are people who would have done anything 100 years ago to get the answers that are in your chemistry book today, or that you can learn from your chemistry teacher, or that you could learn from a Khan Academy video. There are people in the world in the past and today who do anything to be able to understand deeply what this is. They consider it a privilege to be able to learn at this level, and then to think about where this could go, because none of these fields are complete. That we have very partial knowledge of all of these fields. Arguably, there's an infinite more that we can learn relative to what we know. But what's exciting is that we have such a strong start. We're starting to make sense of it, to really describe everything in our reality.